Hello everyone, welcome back to the channel. In this video, we will discuss about Azure DevOps Git repositories. So far, we have discussed what is Azure DevOps organization, projects, Azure DevOps board. Now, let's discuss about the developers area or the programmers area with Azure DevOps, which is source control management with Git or Team Foundation server. To start with it, we'll discuss about the Git and then we'll move to the Team Foundation server in some future videos. Hi, my name is Rakesh Suryavanshi and you're watching Be a Learner. We will start our demonstration from the Azure DevOps URL. So this is the Azure DevOps URL which we have for our organization, which is Be a Learner DV. Now with this organization, I'm going to create a new project called the Git demonstration or the Git demo. And here with the project specification, as we did last time as well, or this particular demo is focused on the Git. So we'll keep this version control system as Git, but you do have option to switch from Git to the Team Foundation server, which is the product of the Azure DevOps itself. We are not interested with work item process for this particular demo, so I'll leave this basic option as is. Let's create a project. So this is our project, and as we have already seen about all these menu items like overview, dashboard, wiki, board in our previous videos. Now in this video, we'll look into the repo menu item, which has the repository configuration. So if I expand the repo option, you have the options sub menu item as the file, commit, push, branches, tags, and pull requests. We'll go into each of these in this demonstration. First of all, let's understand the repos section. So basically, a repos shows the collection of repositories available within this particular project. So you can create one or more number of repositories within a single DevOps project. So in the DevOps organization, you could have one to many projects, and within the single project, you could have one to many repositories. So it's a one to many relationship. By default, when you create a project, there is a repository already available with the project name itself. So if you have a project name Git demo, then you will have a repository called the Git demo. If you can see here at the top, this is the repository which is already given when you created a project. So now you can create a new repository. You can import an existing repository if you like to, or you can manage your existing repository right from here. It's fairly simple. Now, as I said, the default repository is already given to you, and this is the dashboard page for that particular repository. And here on the dashboard page, we have a couple of options. For example, how do you clone the repository on the computer? So there are two options, HTTPS or SSH. So this is the authentication mechanism to connect your Git repository, which is Azure DevOps Git repository, onto your computer. Now you do have option to connect to the existing repository via the same HTTP or HTTPS option, and there are some other options like commands which are given. We'll look into the details of each of these commands in this particular demonstration. And again, we have the import option, and finally you do have the initialization option to initialize this current repository. So if I click here the initialize, then it will initialize the current repository. We'll go into the detail of each of them. So let's first of all initialize it by default, and then I will go into the detail. So once I'm initializing the repository, by default it has added a readme file, and readme file has a default template given from the repository itself. So whenever you create this readme repository, you'll find this template by default, which you can modify. Basically, this readme file is to give the information about your project repository, source control repository, what particular, what is the objective of this repository, what kind of a source code it contains, what kind of a technology stack this repository might have, what would be the purpose of the repository. So all those details you might want to add it here as a summary, so that anybody who is viewing or checking out this particular repository, they would have some level of understanding what this particular repository is supposed to do. Okay, now with that, let's start connecting the repositories to our workstation, first of all, for that, we need to install the Git on our machine. To install the Git, you can simply type Git and you get the URL https://git-scm, which is sourcecontrolmanagement.com. And if you open this Git official website, you'll find the option to download the Git onto the operating system platform which you are using. In my case, I'm using a Windows. Then I can simply download the Windows version of the Git right here by clicking on this download button. So it will download the exe and I just need to run the simple setup. You can also use the command line if you would like to download, and then you'll find all the option here on the download. I have the Git installed already on my machine. So Git is a distributed version control which helps you to manage your source code amongst your team members. If you are working on a project where you have several team members contributing to that particular project, then you need a centralized repository to manage or contribute to a central project repository. And that's when the concept of the centralized repository comes into the picture. So there are two types of source control management system: a centralized repository source control management system and a distributed source control management system. So tools like Team Foundation Server, Maven, these are the centralized source control management system. What does it mean? Is that it requires a server to be configured along with the database. So for example, if you are configuring a Team Foundation server, you need to have a central server for storing your source code or repository content. And you would also require to configure a database, let's say SQL Server in case of the Team Foundation server. And now the team who is willing to contribute to the source control using the TFS, they need to connect to the internet to push or pull the code changes from that centralized repository. It means there is a requirement to have the internet availability in order to work with that centralized repository system. And that's one of the limitation or drawback having the centralized repository in place. So in case if you do not have the internet, then it's not possible to use the TFS or Maven kind of a centralized repository system. Whereas Git is a distributed centralized repository system. So what distributed centralized repository system means that each and every developer would get, each and every user would get their own copy of a repository. So you will get your own local copy of the repository, and with that local copy, you can perform all the activities like changing the source code, committing the source code, getting pull and push to the centralized repository. So in case if you do not have the internet, at least you should be able to commit the changes onto your local copy of the repository. And once you have the availability to connect to your centralized repository or remote repository, you can run the further commands like push, pull to connect and sync to your central repository. That's the difference between the centralized repository and distributed centralized repository. And that is the reason, because the Git is the distributed centralized repository, it is widely used across the world. Even GitHub is using Git as the repository source code repository to manage the source code. Now let's look at some of the basic command to configure the Git onto the machine. So let's say I have installed the Git on my machine, so I can verify the Git version with the command called git version. So that should return the appropriate version which I have. So in this case, the version is 3.2.32. Now once you install the Git, the next thing you might want to do is you might want to set up the Git configuration before you start cloning the repository and start contributing to the centralized repository. So to do that, you can simply run the git config command, git config, and you can simply run the git config list. So that will give you the default list of Git configuration which is been available when you install the Git configuration. It will be mostly in Windows, it will be available under the C user and a user folder, and that will, or there you will find .config file or .git config file, and that will have the content like this. So there are two important parameters mentioned here. Is which is one is username and user email. So that's the global configuration for the Git. So any number of repository which I'll be connecting on this particular workstation, and on those repository, if I let's say commit and push the changes, then this will be the username and email will be available as the identifier, which will have the information like this is the user who has made the changes or contributed with this particular change set. Okay. Now let's see how do you initialize a Git onto a empty folder. So let's say this is the empty folder I have here. And now here with this empty folder, I can simply initialize the Git with the git init command. So let me move to that particular folder with cd command, and then we'll run the git init command. So that will initialize the Git. And what initialization means, it will create a default initialization configuration, which is a .git folder on that particular directory. That is the folder which is invisible. So you need to, if it is not visible, you need to click here on the hidden item, and then you should be able to view the folder. This particular folder would have the informations like object tracking and the configuration, how the Git is going to maintain the change set and track the change set, compare it and push it to the central repository. And as you can see here, currently I'm into this particular directory, and this directory is type of Git directory now. Before that, if you look at, before that there was no master branch sign, which is a Git master branch sign. But now as we have initialized the Git, so this folder has been treated as a Git. So now we have a branch name, which is a master. So what branch means, that Git works as the branching, works with the branching system. It means that you can create multiple branches of your source code repository. So let's say if I am a developer contributing to a particular source code repository or project repository, and I would like to work on a particular feature, then what I can do, instead of contributing directly to that particular master branch or the main branch, what I can do, I can create a feature branch, or I can create a dedicated branch out of the master branch. So source as in master branch or main branch, and then create a clone of that particular branch and call it as a feature branch. And then I can contribute all my changes to my feature branch itself. So how do you create a branch is use the git branch command, and you can specify the branch name. Let's call it as a feature 1. So that's the name of my branch. Now let's add some content to this particular Git repository. So I'll add some Terraform files here on this particular Git repository. Now let's see how the Git exe tracks these changes to check the status of the current changes which we have done. For example, in this case, we have added few files. So I would like to see what are the number of files being added or modified or deleted. So you can simply run the git status command. That will display the status of the current modification which we have made on the given repository. And you can see that these are the 2 files which are being added. And it's in the red color right now because we haven't committed this particular file. And here if you see on the status, it says that on the master branch there are 2 files are being added. Now in order to commit this file into my local Git repository, remember all the changes which I am doing right now, I am doing it on my local repository. I'm not connected to any repository because we have initialized the Git repository locally on my machine. I'm nowhere connected to any of the remote repository. Okay, so I can simply run the git commit command. So git commit is going to be used to commit the changes. -m is to post the message along with the change set. So this is the message which will be available. So I'll say first change. You can give the appropriate name or appropriate message to your commit. No, sorry, before you add the commit, you should run the command as a git add. So that will add the changes to your Git repository. So at the moment status is showing that these 2 files to be added, and you should run the git add command before committing. So let's add the git add, and then here with git add, you can provide the name of the individual file. For example, what is the file name which you want to add? For example, main.tf I would like to add, so I can give the name main.tf. So that will add the file name as a main.tf. And now if I run the git status, then you can see that this is the difference. The new file, which is main.tf, is being colored as the green color, whereas the variable.tf file is still into the red color. You can also run the git add with the dot command. It means you would like to add everything to the Git repository inside the current directory. So I'm into the root directory, which is a demo directory. So whatever changes are available, I would like to add those files, everything into the Git. So once I run this file, it will be added to, it will add everything to Git. And now if I run the Git status, you'll see that both the files are being added. Now simply you can run the git commit command, which we were trying earlier, and with message I can post the message text, which is, let's say, first change. If you look at the logs of this command, these two files being added, and this is the change set number which is being added, used to insert the file, and this will be the change set number basically. With that, our master branch is ready. And if I run the git branches or branch command, so you can see that we have a master branch is the only branch, and the star sign means this is my current branch I'm into. And if I would like to, so all the changes what we are doing right now is onto the master branch, and everything is pushed into directly into the master branch. But in the real scenario, when you will be working with different team members contributing to the same repository, then it is not at all recommended that you should, all of the team members should contribute directly to the master branch. So the way you should do is you should create a feature branch or the dedicated branch out of the master branch, and then from that dedicated branch or the feature branch, you should contribute to your own feature, your own changes, and then you go ahead and merge those changes to the master branch, so that you do not conflict the changes to the same file what the other team member might have done into the repository. So how do you create the branches? You can simply run the git branch command and then provide the name of the branch. Let's call it a feature. You can give any name. I can also give it a name, something like feature login. For example, I'm working on a login feature, so that's going to be my branch name. And now if I run the git branch command again, so that's going to be the number of branches. So features login is the branch which we have just now created from the master branch, and this is the master branch I'm into right now. So now if I would like to switch from the master branch, which is my current branch, which you can see here, I'm into the master branch right now. If I want to switch to the feature branch, I can simply run git checkout and then features login. So that will basically, as you can see, git checkout will check out to or switch to the feature branch which we have created. Now if I run the git checkout with -b command, that will create checkout the branch, and it will create a branch and it will check out to the new branch. Let's say I'll create a dashboard, git checkout dashboard with -b. It means that it is going to switch to the, create a new branch, and it will switch to the dashboard branch. Now in total we have 3 branches, and currently I'm into the dashboard branch, as you can see right from here as well. So now we would like to push these changes to our centralized remote repository, which is hosted on the Azure DevOps. So this is the repository where we would like to push these changes. So this is a scenario wherein we have existing code repository, and now we would like to basically move that existing code repository to a new Azure DevOps project or to a new Azure DevOps project repository. Let's see how do I do that. So if I try to push, run the git push command, which is the command to use to push the changes to the remote repository, I'm getting this message that you cannot directly push it. So what you need to do is you need to simply run the git remote add. It means that you need to add the remote repository link to your current repository. So I can simply run the git remote add command, and you can provide the name of your remote repository. So in this case, name is, let's say, git demo. So that's the name, and next it is asking for the URL. So I'll copy this particular URL with HTTPS authentication mechanism, And as I've copied the HTTPS mechanism, is because of that the URL contains the HTTPS. Now if I press enter, that should basically add a remote repository here. Okay, and now I can run the command git push, and then I can use the same git command name basically to push the changes. As we are doing for the very first time, and we are doing it not from the master, and we are doing it from the feature branch, so git push directly will not work, and you need to set up the upstream branch upstream configuration, so that we are saying that I'm okay to push the changes from the feature branch. So that's, let's make the my feature branch on the git repository as this setup upstream. So that is what you need to run this command git push with the additional parameter. So I'll run the git push as the additional parameter set upstream with the branch name or git repository name and the name of my branch. Now if I run this command, that should basically push this branch into my remote repository. So what it will do, it will create this branch and push the changes. So now if I look at here, currently we do have just main branch, but if you look at here now, we just now created a new branch, and this is the branch which is just now checked in, and that's the change set which we have given on change set ID. Okay, so this is how you can push the changes. Now there is a scenario, let's say you do not have the existing branch. So what you can do, you can simply clone this particular repository and then start pushing the changes. So we'll look at that scenario as well. First of all, as we have pushed the changes not into the main branch, our main branch is still empty as you can see, but we have pushed the changes from the feature branch. So that's the reason you are getting this message which says that you have updated this particular branch and you are ready to create a new pull request, because Git knows that we are making changes to the feature branch, not directly to the main branch, and the main branch or the master branch is basically the branch which we want to keep up to date, and that's why it is saying that please create a new pull request. So what is a pull request? You can create a pull request to merge the changes from one branch to other branch. So as I mentioned that you have these branches here, and if you would like to create anytime if you would like to create branches from this GUID or from this web interface, you can click here on the create new branch and you can create a new branch, or you can use the command which I have shown you, git space branch and the name of the branch basically. Okay, now let's create a pull request. If I'm going to create a pull request, this is the menu item we are into. So we were on the files item, and as soon as I clicked on the pull request button, I'm navigated to the pull request menu item. And here in the pull request menu item, this is the user interface looks like. So you have the source branch location from where you want to merge the changes, and you have the destination branch location, branch name on which you would like to merge your changes. Here you have the overview section where you need to provide the title of the changes which you are pushing. Let's say I'm adding my changes, so I can give any changes. Okay, login changes for example, or dashboard changes. Okay, and then this is the description. You can add the reviewers as well. So reviewers are going to be the person whom you, or group name you would like to include as a reviewer to review your change set. Work item ID. So let's say if you are working on this particular change set against any product backlog item which we discussed last time in our board section, so you may want to contribute or attach the change set number to a specific task. So that's the task number which you can attach here with the Git. So if I click here create, it will create a new pull request, and the reviewer will get a notification if I have added a reviewer that this particular pull request is waiting for your review. Now we have two different tabs here. You have a tab called files, so where we have the number of files which is being modified as part of this particular pull request, and then we have the number of commits which are being made on this pull request or on this particular source branch at the time we are doing the very first pull request. So let's create this, and then it will be available as reviewer to review. So reviewer will have this particular user interface, same thing, and then reviewer can go ahead and provide the review comment right here from this particular section. So let's say if I would like to add something, then as a reviewer I can say add comments about this changes, something like that, and I can just simply push that. So what it means that the developer would have a review comment, and then review comment would be this is the review comment, and developer can either, let's say, fix that particular review comment, or the developer can provide the follow-up message that this changes is being successfully done, or it is done as it is expected. And then once it is, as you can see, current status of the review comment is active. So let's say I make the changes and I can simply reply and resolve, or simply resolve instead of reply instead of resolve, and then the status will be changed from active to resolve. Okay, reply and resolve, and you can see that who has made the changes. You can get the idea that Rakesh has added the comment and who has made the changes. The same history of the review comments you will get here on the overview section. So you will see so many entire tracking of the changes which we are doing with the review comments with this particular section. So this is really helpful if you are working on a larger project with multiple team members. So this is what it is about the pull request, just a basic summary. Okay, and here on the commit section, basically you will see that we have the number of commit which are being made onto this particular selected branch. So if I select back to the main branch, I'll get the commit this, because we haven't merged that particular changes. So let's go to the pull request back again, and here with the reviewer, at the moment I haven't added a reviewer because I'm the only user on this particular organization. But as a reviewer, I can either approve it, approve with suggestion, wait for author, or I can reject it. So let's approve the changes, and then I can basically complete it upon the pull request. That is also possible. So let's approve these changes and complete it. So once I'm going to complete the changes, these are the three options which are available. First option, if you have the work item linked with this particular pull request, do you want to close that particular work item? That's the option number one. If you have the merge successfully, then do you want to delete this particular branch after successfully merge? Because you are merging the changes, it means your feature has been completed, or your work for with the feature branch might have completed. So you want to get rid of the feature branch. So that is the option. So if you make this option selectable, it will complete the pull request, and as well along with that it will delete the feature branch as well. So now as you can see, it is merging the pull request. It means it is merging the changes from this dashboard branch to the main branch. And now if I go to the files, I just have main branch, because as we have seen that the checkbox says that it will delete the feature branch. So it has deleted that particular feature branch. Okay, now if I go to the commits, I have these many changes. So that was my original change when we have created the Git repository, and this is the new change which we have added to our feature branch, and then this is the merge change. So that was the change. So in each of the changes, if you look at, we do have the different change set ID, and which you can click here on individual change set ID and find the difference or compare the differences of the each and every change set. Okay, that's the push, which is about how we have pushed the changes to the selected branch, which in this case main branch, how we have pushed the changes to the main branch. And this is where the branch section. So there was a option to create a branch here on the repository section, but you do have the option to create a new branch here at the branches section as well. So I can anytime click here on the new branch, and from here I can simply create a new branch called, let's say, feature called F1, and from which branch your new branch will be based on. So this is the branch name which you need to select. So let's say in this example, I would like to select the create new branch out of the main branch. So if I create new, there will be a feature folder. Inside that there is a F1 branch which is created. This is the branches which are being managed by me as a user, logged in user, and that's why you'll see your own branches. But you do have the alt tab as well. Let's say if other team members are also creating their own branches, then if you want to see what are the different number of branches available with this particular repository, you can see all those branches here with this alt tab. Now here with the branches, we'll look into the branching policies. You can define the different branching policies. You can add new branch right here from this particular option. You can delete the branches. You can view the files, view history, add a lock to this particular branch. So always best practice to add the lock to your main branch so that nobody deletes the main branch by mistakenly. So it is always recommended that your main branch is being locked. Okay, then you can add a branch policy to your branches, which we'll look into the detail later on. Now let's take a scenario wherein we would like to, let's say we have this particular repository and we would like to clone this repository onto our virtual machine instead of creating right from the local computer and pushing it here. So in order to clone it, simply you can copy the URL and go to the folder where you want to run the clone. So let's say I have a demo1 folder. So on this folder, I'll switch, first of all, I'll switch to this particular folder location. As you can see, we do not have any Git repository on this particular folder. That's why when I run the git status command, I'm getting this error. Now to clone the existing repository, existing DevOps repository on this folder, you can simply run the git clone command and you can provide the URL of your Git repository. This is the URL. It will ask for the authentication, username and password. You can simply provide that username and password certificate. Sometimes you might get this particular error, which is it's not able to communicate back to your remote repository with the SSL authentication. So you might want to rerun the command. And as you can see, this time I'm successfully able to clone this repository onto this particular folder. And now if I run ls command, I should have this particular folder which has been created. I can simply move to that folder. And now if I again run the ls command, these are the files which are being available with this folder. Okay. And as soon as I have moved to the Git folder, I'm getting this icon, which is the Azure repository. And this is the Git icon with the Git branch name, which I am in right now. And this is the Azure icon, which says that this is a Azure repository, Azure DevOps repository. And now you can simply do all your changes, create git checkout b test. This is the branch. So it's basically created the branch here. And now if I see, these are the two branches. I am into test branch, so I can simply add new file to this particular branch. So now if I go to here and if I add the new file, let's add it a new file called the terraform.tfvars. If I run I've added a new file. If I run the git status, it should show a new file is being added, as you can see here. In your project, it might possible there are some scenarios in which you don't want to add certain number of files or certain specific type of extension, file type extension which you don't want to add to a repository. If that's the case, then you want to ignore those changes, for example. So what you can do is, you can simply, in such cases, what you can do, you can add the gitignore file. So for this, you can add a new file called gitignore, which is .gitignore. That's the file name which we should add. So what this particular file will do, it will help you to make a decision which file type or file name or file extension or folders which Git needs to ignore while performing the check-in checkout activity. So for example, if I add the terraform.tfvars, I'll add it, save it, and now if I run the git status, As you can see, earlier it was showing that this is what the file name it is going to add, but now it's not showing that particular file, it is just showing the gitignore file. Now if I commit the changes, git commit, if I add the changes first of all, so that will add the git file, and I'll commit the changes to this file, ignore file added. We'll add the git push. Again, we need to set the upstream because this branch was created locally. So what does it means is, even though we have these many files, which is terraform.tfvar and these files, but we are just trying to add these remaining file apart from the TFVR, and we managed to do that with the help of gitignore file. So whenever you would like to ignore certain file extension or files, then always add the gitignore file, and then that will help you to make a decision which file you want to add or which file you don't want to add, for example. Okay, so this is how you can persist, you can manage to push only a specific file type. Now if I refresh again, I should have new branch called feature, which is test, and with this test we have a gitignore file, which again I can run a pull request and merge to the main branch like we did last time. So that's about the Git and some basic operations. How do you work with Git with your projects, especially into Azure DevOps. I hope you have found this useful. If it is, please give it a thumbs up and don't forget to subscribe to the channel. In the next videos, we'll look into the detail about the continuous integration, continuous deployment. How do we deploy the application source code with the help of Azure DevOps pipelines? Thanks for watching it. See you in the next video.